and it's my pleasure to introduce George Bonner. He serves as North Carolina's Director of Renewable Ocean Energy, leading research and development of marine energy solutions across the University of North Carolina system. Following retirement from a 30-year career as the U.S. Coast Guard in July 2019, Bonner returned home from his position returned home to his new position at the Coastal Studies Institute of North Carolina at North Carolina Outer Banks. Captain Bonner is a graduate of the U.S. Coast Guard Academy, has a Master's of Science in Engineering from the University of Illinois, and a graduate certificate in coastal engineering from Old Dominion. And are those slides working okay?
There we go.
Perfect. That looks great.
All right, thank you so much. Like was mentioned, I grew up here on the Outer Banks in North Carolina in Manio, and spent 30 years in the Coast Guard. So it's great for me to come back home to the Outer Banks into North Carolina and to get involved in something that I'm really excited about. I spent most of my time in the Coast Guard dealing with some of the devastating forces of our oceans, protecting the mariners, dealing with infrastructure issues. But now I get to take that same energy and do something productive with it to try to help support our clean energy goals for North Carolina and for the nation. So first, I just wanted to thank you for the opportunity to be here this afternoon and to talk about marine energy. You'll hear us often refer to marine energy or marine hydrokinetic energy or ocean energy. They all kind of mean the same thing. It's harnessing the power that from our marine energy resources. And today I want to talk a little bit about what are some opportunities, how can we power North Carolina's blue economy or the things that are along our coast. And I wanted to thank each one of you for your commitment to our young people in enhancing our STEM programs. You guys are on the front lines and it's really important. And our world's changing really quickly. And there's emerging challenges and demand for a workforce with a strong foundation in STEM. And as an engineer and a manager for the last 30 years, I've really seen how important having that strong foundation is, especially getting it early on in elementary school, middle school, and high school. And as a parent of 3 kids, I also know how tough it is and some of the challenges it is for our educators and how different it is from when I went to high school over 40 years ago. And what can we do to show the value of the STEM education, how important those courses are and that curriculum is, how they can help make a difference when they get out of school and join the workforce. And I wanted to share this quote here that kind of highlights some of the biggest challenges we're facing. And I wanted to start with this quote from John Kerry from a recent Ocean Climate Summit that captures the importance and the linkages our oceans share with the impacts of a changing climate. And marine energy provides enormous opportunities to support our decarbonization and support our clean energy goals. But we also want to make sure we're doing it in a responsible way and we're being good stewards of our ocean resources. All right, it's not transferring. I got to go back. I got to stop sharing and go back here. Hold on.
Sometimes I have to click my screen twice to get it to advance. So that might be what you have to do too.
There we go. All right. So in my job now, I get to work with researchers across the whole University of North Carolina system. And we have an annual symposium each year where we bring researchers together and we collaborate. And this just captures one of the word phrase exercises that we went through at our symposium in the fall. And I think it highlights a lot of the challenges with marine energy. Marine energy is a new emerging technology when you compare it to other renewables like solar and wind energy. But it also kind of captures some of the excitement that's out there with this emerging technology and the resources that are there. There's a lot going on around the world with marine energy, especially in Europe. The US is currently lagging as far as deployment of marine energy technologies. But I think that we're starting to see a shift and a lot of opportunities on the horizon with marine energy. So if we could do the first poll now, possibly, the poll questions I sent. Okay, there we go. So what marine energy resources do you think offer the most potential for North Carolina?
Yeah, they're answering quickly.
Yeah, yeah.
This is a tricky question, I think. A couple more seconds. All right, it looks like most people have voted. Let me end the polling and share the results.
And I'll apologize. I see an error in the options. The one below river currents, ocean energy. That was supposed to be ocean current.
Oh, that might have been my typo.
Yeah. So either way, but I think that you guys are actually on it. So North Carolina has tremendous wave resources off our coast, and it's probably the best option in the near term. And then we're also fortunate to have the Gulf Stream off our coast, and Mike's going to talk about the opportunities in the Gulf Stream a little bit later. But wave is probably our most near-term opportunity. We don't have a lot of tidal resources in North Carolina, and we don't have a lot of ocean thermal opportunities, but we do have an abundant wave energy climate. And this graphic here just captures kind of the resources across the U.S. and our coast. And you can see that we have a potential for over 2,700 terawatt hours per year, and that could easily power over 2/3 of the U.S.'s energy demand if you're going to tap into all that. And it doesn't make sense from an economic standpoint that you would rely completely on marine energy, but I think it just shows that there is a tremendous opportunity there. And in the U.S., the wave energy component is the largest one of those components, with over 18 terawatt hours per year. All right. There we go. So what are some of the benefits of marine energy? It can be predictable, especially for tides. You know when those tides are coming and when they're going to peak. It can be weather independent, unlike some other energy resources. Water is very dense, so it offers some unique opportunities there. Unlike wind energy, you could have devices that are on the bottom that people don't see. It doesn't have some of those impacts to a tourism economy, and people don't have to look at it. That could be a benefit. So those are just some of the benefits that marine energy offers on how it can complement other renewable energy resources. So what are we talking about? What technologies do we use to harvest marine energy? So these are the top 5 technologies that are out there, and wave energy is one of them. And there's many approaches our developers have developed wave energy converters to take that wave energy and produce energy. And some of the types are point absorbers, where you have devices that float on the top of the surface and go up and down as the waves go transfer. And they require an anchorage system where they're anchored to the bottom. You have floating attenuators that look at the relative motion of the surface and changes in that. And then you have wave surge converters, where you have like devices that are on the bottom that move back and forth as the waves move across the surface. And then you have tidal energy, and usually those involve some type of turbine in the water. And an example of that is there's a tidal device that's installed in the East River in New York City they recently went through an upgrade. And so that produces power on the East River right next to Manhattan each day. And then there's river currents, and this is an example of a device that's installed up in Alaska, and it helps provide power for a village up in Alaska, so they're not dependent on shipping in diesel fuel every week to provide their energy needs. And then ocean current, that would be like tapping into the resources in the Gulf Stream, and Mike's going to talk about that. And then ocean thermal is relying on energy that's stored in different layers in the ocean, and typically you find those in tropical and subtropical oceans. Marine energy offers many diverse opportunities for career paths. Like I mentioned earlier, it's an emerging industry, so a lot of the current opportunities are for engineering, and that could be anywhere from mechanical to aeronautical engineering to chemical to civil engineering. and then a lot in the environmental sciences that are important to make sure that we do things in a responsible way. But as more technologies get deployed in the US, you're going to see more and more opportunities to support the supply chain, as well as the continued environmental permitting and monitoring required. And throughout my career, I've just seen how important having a diverse workforce is, especially to driving innovation. And I know that's a challenge, like in many of the engineering fields, and especially in marine energy. And we want to continue to look for opportunities and how we can close those gaps and have a more diverse workforce. So we talk about the blue economy. We mentioned, like there's power needs along the coast. And these are just some of the examples of what we call the blue economy and where marine energy could help support powering those blue economies. One example is a lot of our communities, our islands, our remote communities, and typically when storms come or when there's something, we're the first ones to lose the power and the last ones to get it back on. So how could renewables and even marine energy help provide power to build resiliency for the grids in some of these communities that are most vulnerable? Another example is we have the second largest state-run ferry system in the country. And the goal is to reduce the carbon footprint of these ferries and move towards electrification of the ferries. And how could marine energy help provide power? Because obviously the ferries are operating in coastal communities. How could it provide power for that? And then another option is, we have water challenges in the US and around the world. And marine energy provides a power source to help drive desalination of water and run reverse osmosis systems. And in the middle right picture there, that's an example of a technology that was developed by a team from NC State and UNC Charlotte to help a wave powered desalination system. And we're going to talk here in a second about some other things we're doing to advance those type of technologies. So those are just some of the technologies when we talk about powering the blue economy and where marine energy can make a difference in the near term. Currently, the levelized cost of energy or the cost to produce energy compared to other renewable sources is not there. It's a higher cost. So, these blue economy applications provide opportunities where it may be cost effective in the near term. And the goal is eventually the levelized cost of energy will drive down, just like it happened with solar energy and wind energy. We mentioned wave power desalination. So our team at the Coastal Studies Institute, we're working with the Department of Energy on hosting a competition that's going to bring in innovators from around the country that are working on wave power desalination systems. And we're going to test those devices next spring in April of 22. So we're excited about that. And we're going to have lots of opportunities with outreach where hopefully get more kids involved and see firsthand how these technologies work and use that as a STEM outreach opportunity. And I wanted to mention some opportunities here are some resources that are available from the Department of Energy. Here's a couple of links, and you can find some different tools, and there's some lessons that are available on these websites. And I know that the Department of Energy is working hard to update these as well, and they're having a meeting in May focused on increasing the resources that are available on these websites. And that's what I had for now, and I'll open it up for questions. Or are we going to do questions at the end?
Yes, we're going to do questions right now, and there's a few in the chat. So there's a question about ocean thermal energy conversion, and have there been any breakthroughs in that in the last couple of years to make it more feasible?
It hasn't been a focus area of our program here in North Carolina. I know in other parts of the world there have been advancements, and I'm probably not the right person to ask about that because we really haven't been focused on those. And I'll ask Lindsay or Mike or Michael if they have any more on that one.
I think this is Mike. I think George is correct in that typically what you want for ocean thermal energy is very near proximity to very deep water, so that you have that large temperature gradient, which we don't have because we have a shelf here that it's miles and miles offshore before we have access to that. So it hasn't been a focus of our program for North Carolina, but in places like Hawaii, where you don't have to go very far offshore to get to waters 4,000 meters deep, they're working very hard to develop that technology.
And there was an OTAC plant that was planned for a resort somewhere. I think that it was in the Caribbean. It was a Japanese company, or no, it was off the coast of Japan. I haven't checked back in on that, but that was probably the most recent developments that I've seen for OTAC.
And then the next question from Julia, that's a really good question. So anything that we put in the marine environment or in the ocean, it's a harsh environment, obviously. So corrosion is a major challenge. And so there's some really neat research going on technologies, whether that's using magnetic transmissions where you can reduce the operation and maintenance cost of putting devices in the ocean, or using materials. So in NC State, they're focused on some really unique materials where you can reduce corrosion requirements. And then, yeah, so it's a harsh environment, and that's definitely a challenge with deploying any type of technology. And there are no ocean thermal projects in North Carolina that I know of. And Lindsay and Mike, do you have any? No. Okay.
I think that's correct.
There's one additional question from Julia. Is the reason that ocean energy is so expensive, I'm not sure if I'm reading that correctly, just moving electricity onshore, is that what makes it expensive? I think that's what Julia was asking. Correct me if I'm wrong, Julia.
I think it's a number of factors. So we mentioned just the marine environment's a harsh environment, is number one. Number two is, there just hasn't been a lot of demonstration projects. It's a relatively new industry. And I think that, through more testing and demonstration projects, we can drive the cost down to make it comparable with other renewable energy solutions.
Yeah, an example of that, and George's right, is we're a very young industry. So if you think about solar and wind, we're talking about 50 and 100-year-old industries, right? So it's tough for us to compete as a new industry with the cost of solar and wind power. But you've seen with technology, the prices for energy from those sources go way, way down, right? Where it's much more competitive with fossil fuel energy. And so it just takes time, I think, to develop the technology.
Yeah, and then JD, your question about the not in my backyard factor, that's a really good question too. So obviously engaging with stakeholders is really important. And there's a lot of competing demands in the coastal environment, and making sure that we do things in a responsible way. Like I said, we got offshore wind being developed off North Carolina now. It's a large lease, the Kitty Hawk lease, which is just off the coast here. You have commercial fishing, transportation, recreational uses, and making sure all those things are done in a responsible way is really important. And Lindsay and her colleague Linda, they've been leading some stakeholder engagement efforts. And we also just found out that we're going to be part of a new National Marine Renewable Energy Center called Atlantic Marine Energy Center. And one of our focuses on that is doing stakeholder engagement along the East Coast and beyond, to make sure that we're talking to the right folks so that we can understand what the issues are, and as things are deployed, they're done to meet all those competing demands. Lindsay, I don't know if you had anything else to add to that one.
No, I think you did a great job. I was trying to put your links in the chat box as someone asked, but I'm not fast enough at typing.
Okay, I'm gonna let Mike take the next question. Can you see the questions, Mike?
Yes, I can. So this is: knowing that energy is neither created or destroyed, what are the negative consequences of drawing energy from the tides? Wouldn't this accelerate the loss of angular momentum with the moon? What will eventually happen when all the energy is gone? Will the moon be further away and then in geosynchronous orbit? Is the energy from the tide echoes from a past collision in ancient Earth history? So that's a lot of questions. The short answer is no. The tides are caused by the gravitational force from the moon and from the sun, and then the motion of the bodies makes the motion of the water on Earth. So it's not like it's difference, I guess, between the force and the energy from the motion of the body. So you're not actually removing energy to where you change the orbit or rotation of the moon and the sun quite directly like that. You're actually removing the energy from the water wave on Earth. And so what that means is you could reduce the tidal influence, say downstream of the wave, I guess, if you remove some of the energy. You certainly would do that. But yeah.
Thanks, Mike. And the next question is, what European countries have made the most advancements in ocean energy? And I would start with Scotland, is where the European Marine Energy Center is. So they lead the testing and deployment in the EU, and they've got a lot of devices deployed, and a lot of those have led to commercialization of a lot of those technologies. And I think one difference is they have a large tidal resource in parts of Europe. So they've used turbines that tap into that tidal energy, but they also have a lot of wave energy converters and different types that you'll see deployed from everywhere from Portugal and Spain. And we're partnering with the European Marine Energy Center as part of our stand-up of this Atlantic Marine Energy Center, and working with them on getting accredited for our testing programs.